welcome to the channel. Today is a UCC update about our race truck. We're going to talk about these awesome engines right behind me. Alright guys, last time you saw an update on this UCC build, it was me and Josh. We were talking about putting the truck on a diet. We're trying to cut a bunch of weight out. And I said the next one's going to be about the engines. We've been working a lot on these engines. These are a custom one-off engine. The great thing about a one-off engine, it's like a puzzle. It doesn't go together like a Cummins engine that's just normal and everything fits. You kind of got to make everything work. Every time you put one together, it's been the same story. It always takes a lot longer than you think.
Like 3 weeks or 4 weeks to do a 2-day job.
Oh, it's crazy. But in the end, these things are freaking sweet. So we're going to actually walk around with the camera and show you all the cool things we put on these. Talk about the different parts we're using, talk about why we're using them, and yeah, it's gonna be awesome.
Yeah, and you get to see how beautiful they look before the carnage. Assuming, well, that's kind of a big, bold statement. Yeah. They're not gonna blow up. They're gonna hold this year.
Yeah. We're
done blowing up engines. I promise you.
Yeah.
That's why we're bringing 2.
Yeah. All right, so we're going to start off with what we're calling engine number 1. This is our engine we're going to start out the competition with. And let's just start here at the front. Starting off with, this is a fluid dampener, but it's not a normal fluid dampener. This is a competition one. There's no ribs to run a belt. It's just a dampener. The thing I like about it, it's a little bit larger, a little bit heavier. It should do a little bit better job. Also, you'll notice right here, this is called the Fluid Dampener Full Power Kit. If you watched our video last year, we did a video called We Go Racing. And in that video, we did one pass, really half a pass. And in that pass, the bolts all came loose, and we had a big mess there, right there at the track. And so it's a common problem with aftermarket dampeners. The bolts get loose, the high RPMs, all the vibrations, really bad. So Fluid Dampener came out with what's called their full power kit. And this actually was on the engine that blew up. So this thing went to 8,200 RPM, and when we blew it up, the dampener was not loose. It actually held on. So they actually did solve the problem. It's much, much better now. So anyway, can't recommend this thing enough if you're going to run some real high RPMs. And so Fluid Dampener is first thing. Working our way back, we have this is the cover we made. We made this last year. You'll notice our cam support. We broke a cam and a cam gear last year because we didn't have a support on there. So actually, once we did the support, the gear broke. But so we fixed that with the cam support. What kind of gear are we running though?
So after we broke a gear, we called up. It was actually Kenny's Pulling Parts. He makes an adjustable billet gear for the cam, and it's really great for degreasing the cam, but also it's really strong because it's solid. And so this has an adjustable billet gear from Kenny's Pulling Parts in there. And it took a little bit of extra work to make it fit because it's a little fatter, so our cam support, and like I said, it took a long time to make it all work perfect with this cover, but it was well worth it. So we got a billet cam gear in there.
Yeah, the gear is actually so fat, and in a stock gear, you have the gear part, and the webbing is thin to the center of the gear, where this one's like solid. And so there was not enough room between the gear and the gear housing to have a bolt. Like before, you just run a normal bolt, it's not a big deal, you go through. Well, on this one, we actually had to change the design of the gear case itself in order to allow for a bolt that's a flush with the surface of the gear case. And so we actually had to change that too. So yeah, there's a fair amount of work, but now all our gear cases are changed. So if you want to run a billet gear, you do not have to modify your gear case. Yay!
Now. So in here we've got a modified 8.3 oil pump. Took a little bit of work, machine work, to make it fit, but I think our idle oil pressure went from what 40 to like 75 psi when it was warm.
How much more volume does the 8.3 flow per revolution than the 5.9 pump? Do you know?
It's right about 30% more oil flow.
So the same RPM, 30% more flow, new multiple turbos, it's a good idea.
Okay, so with this high flow oil pump, we wanted a better oil system, a better way to regulate it. We were kind of fighting the factory pressure regulator. They're designed to open at 60 to 75 psi, and we wanted to crank the oil pressure well over 100. So we went with No Limit Manufacturing, made this nice billet oil setup here. It still has a factory cooler back there so we can cool our oil, but this actually has an external regulator, and so we can change the pressure that goes to our turbos. We can have full unregulated pressure out. We can let the motor get, you know, as much as the oil pump will make. I mean, maybe even 150 psi of oil pressure if we want. Has a great big oil filter, and it's really going to help with our oil system, keeping our pressure high, because that's something that we struggle a little bit when the engine gets hot with an internal oil pump, is keeping your pressure up. A lot of guys, when they build a race engine like this, they do this big monster external oil pump, belt driven, and we like the simplicity of gear driven, all contained in there. And honestly, these are parts that the regular guy can put on his own engine build and saves a lot of money buying a modified 8.3 oil pump from us versus a whole standalone system. So
Yeah.
moving along, let's go up here towards the top end a little bit more before we get into the guts of the engine. What about this head?
Yeah, this is the warhead that we've been running for a long time. This actually survived. This is the same head that I blew up. This was the head that came off that blow up, and it came out looking really good. Like the only thing, but it survived. And so this was there. This is the warhead.
This is an original warhead. This has been to UCC twice.
It's been to UCC twice. That's absolutely
third time's a charm.
That's right. So and above that we have this is like a girdle. This is an SMT. There's a couple different companies who make a version of this. So this is a girdled valve train. The rockers are way better. The ratios are better. The angles are better. Super strong setup for valve train.
So it's got roller rockers. They have oilers built in that spray oil on the springs and stuff to keep them cool. Really neat trick stuff. This seems to be what all of the top high RPM guys, and this happens to be the valve train we tested to 8,000 RPM, and it survived. I mean, this is the same setup that went to all that RPM. So
one thing you should know about this particular rocker setup is, as awesome as it is, it will not fit in your stock second gen engine bay. You got this extra ½ inch or 5/8 thick girdle here that pushes your valve cover up. It's a one-piece valve cover, and this will not, you're not going to be able to get the bolts out, and you cannot get the valve cover off with the stock cowl. Now on my race truck, I've cut that all away, so it's not a big deal. So when you see this, you'll see it on like sled pull trucks that have the tilt-up bed or something that's highly modified. So as awesome as this is, it's not exactly
it's not a street setup.
Not really a street setup. It's really a performance race type setup.
And it should handle street use, but it's just not practical with a factory body.
Yeah, if you have this engine in something that has tons of room in the back, go for it. But in a Dodge body, not a fit, as awesome as it is.
So moving on, we've got the same style side draft intake we used before. This is from Keating. This is a new one. The other one got all bent up and mangled when the engine blew up. We've got some added bungs. We're putting water injection in each of the ports, just like we did before. So we can tune the exhaust temp per cylinder. You know, if you get a hot cylinder, you can't keep turning up the power. You'll burn that piston and melt that hole down. So with individual water injection per runner, we can make the nozzle bigger, put more water in number one if it's running hot on the data logger, and then we can turn the power level of the whole engine up. So individual water is very important, and it's a very important part of tuning at the highest level.
We're actually using the very same pump that we had in the blow up. This is our 16 millimeter Ferrell diesel pump. Now, truthfully, when the engine blew up, it damaged the case. So this is a new case, but all the internals are the same. Same cam, same DLC coated plungers, tappets, all the good stuff that's in there remains. So this thing survived 8,200 RPM. The internals were great. So you can make a lot of RPM with this pump if you can have the engine built to handle that kind of RPM. So didn't have a hung rack. A lot of people wondered why it ran away. We told you in other videos, but we had a broken bracket and the throttle return springs didn't work. And when this thing's full throttle, it hydraulically wants to pull it to wide open throttle, so you need to force it back off. So anyway, that's kind of what happened to the pump. So yeah,
some new lines this year.
Oh,
you want to talk about those?
These are huge lines. But this line right here, this puny little thing, this is 120,000. This is the biggest line that most people try to get. You get a stock line, a 083 or 093, 120 walls. So this is a 120. These are big lines. These are bigger lines. Bigger lines are better lines. Why do we go so big on these?
So we went big on the lines because we wanted to test the theory that some of your injection is lost in line swell. And our thought is if we stay 120 on the ID, which matches the passage in the injectors and the passage out of the pump and everything, but if the line is heavier, it will swell less and therefore should deliver or maintain higher pressure to the injector. So just a little thing we're trying. That's why we have the old line set up and the new, so that we can figure out what makes the most power. But I have a hunch that, we might find another, 30 or 40 horsepower with this. I don't know. The other advantage of them is they should be less prone to cracking because there's just physically more material in the end where they're swedged. So we're hoping with these big gnarly lines, we're going to fix some of the cracking issues. So hopefully there's some reliability gains going to these big lines as well.
One thing we've upgraded this year is our power steering box. In the past, we've always used the stock factory Cummins vacuum pump, which mates to the power steering. What happens is at really high RPM, the gears like press fit onto the shaft, and it actually will spin. When it does that, it breaks. When you break that, you lose your power steering. So I've lost power steering, I think, twice. Trying to get back to the pits is pretty hard. And so we've actually got a cool thing here. We found a guy who deletes the vacuum pump portion of your power steering. So this right here, you'll notice, has a nice little billet piece here that just drives your power steering pump. What's really cool about it too is there's no oil feed to this. Your vacuum pump needs an oil feed. This does not. And so there's no oil leak or oil feed that you have to do to supply that. So it makes it more compact. It's really cool, and I'm excited that I won't have the possibility of losing power steering again this year. And then another thing we put on this engine that's not really for huge performance, but it is awesome, I actually really like it, is this silly little fuel pump block-off plate. Every engine that doesn't run a mechanical lift pump needs one of those. And there are some real cheap steel ones out there we've run in the past, but since we have the ability to make cool stuff, we decided to make a real awesome billet block-off plate, so that's really pretty neat. I actually love that. I think it looks awesome, so there it is.
Okay, so moving up onto the top of the valve cover, we have these two fittings. These are from Vibrant Performance, and this SMT valve cover came threaded and set up for O-Boss fittings. O-Boss is like an O-ring boss. It's a more modern hydraulic fitting. They're less likely to leak than, let's say, pipe threads. But we had to get these nice fittings from Vibrant to utilize these O-Boss ports. The reason we have these is we cool our oil and we return it to the valve cover, let it cascade down the engine, pull extra heat out of the engine when we cool the oil. Well, getting over here on engine number 2, we have this nice Keating cover that will fit under a factory cowl on your truck, but it's shorter. So Vibrant hooked us up with these female O-Boss 12 bungs that we were able to weld on there so that these engines are totally reverse compatible. Because if we have an oil system on this engine, we need it on this one. And to make the heights line up for our hose lengths and stuff to clear turbos, we had to do that. So just kind of a simple little thing, but when you're building two engines, they might as well be a good backup of each other. You know what I mean?
Yeah, I mean, last year we stayed up all night building an engine. We're really hoping to avoid that this year. If we do have to swap an engine, which I don't think we will, but should that have to happen, we want to make it as easy as possible so we're not up all night building an engine in the trailer, putting it in the next morning. So the last thing on the external part of this engine that's really interesting that we use and we have used for a long time is the speed manifold. This one actually went through the crash. This one went all the way up and blew up and survived. Now, all the fire retardant from the fire extinguishers kind of made it a mess, so we kind of hit it with some powder, some header paint, and so it's not quite as beautiful as a normal speed, but functionally it's perfect. Also, you'll notice these. I talk about these a lot because I just love them. I love them so much. These are our locking fasteners that we sell, and I've had so many bolts back out. If you get a high RPM, high performance engine with these short little bolts, they're just going to back out. Stock Cummins ones won't, but these ones I guarantee you will. So these things do not back out, and ever since I found these, I will not have an engine that I have performance without these because I hate tightening bolts, having a big sooty mess underneath my truck. So really like this setup here.
Okay, so now we're going to move down to talking a little bit more about the bottom end of these blocks. Both engines are solid Hamilton blocks, so there's no cooling passages in the block. They are solid iron. Moving down, that seems to be really reliable. We've never blown up a cylinder, so we kept with the solid Hamilton blocks. One issue we're having is we felt like the old girdle we were using wasn't up to the task. So this engine we went with No Limit Manufacturing, and they hooked us up with a 3/4 inch thick girdle, billet main caps, and they're cross bolted. So engine number 1 has the stoutest bottom end we could put together for this setup. Engine number 2, if you come over here, this one has a 5/8 inch thick girdle on it. This is from Kenny's Pulling Parts. This also is quite a bit heavier duty than what we ran before, and it'll kind of be fun to run both and see what the bearings look like on both. Hopefully they look great, but you never know. Moving internal on the engines. Engine number 2 has leftover diamond pistons that we had from some of our previous engine builds. So this actually has used diamond pistons with brand new total seal rings. And then this is fitted up with Carrillo rods. We've got the Carrillo HD rods in here, and we're really happy with how the Carrillo rods handled the high RPM. We did have rod bolt failure, but you know, it was a lot of RPM. We didn't bend any of those rods making power at UCC, so we're happy. So we put the Carrillo rods. On this engine, we ended up working with Wagler, and we have their heavy-duty billet rods, which we have used a set before at UCC, I guess on our backup engine, but we cracked that block, so we didn't really get to work them hard. Yeah. So we put the Wagler rods in here, and they have a 1/2-inch rod bolt, and this has brand new diamond pistons in. They're a little bit different design, a little bit different coating on them, a little bit different ring package. Just testing out some new stuff on engine number 1.
All right, so a little different setup on these two engines is the camshaft arrangement. In this one, we have the billet gear with a tool steel camshaft, really strong material. On this one here, we're running a Hamilton steel camshaft with a USA gear. Now last year we broke a camshaft and a gear, but we solved that with our little cam support here. And once the gear broke, we were kind of scared about it, but then we talked, was it Hazley we talked to? Actually, we talked to Hazley at UCC, and he said, the German gear you broke are prone to breaking. If you get a USA gear on there, you'll be fine. So that's what we did last year. In the middle of the night, we put a USA gear on there, and we hit it hard in the dyno, hit it hard 2 times in the sled pull track, and so it did hold up really well. So we're pretty confident in that. So we have that in engine number 2. So
we actually took that to 8,200 RPM as well.
We did 8,200 RPM.
We had the Hamilton cam and the USA gear steel.
Yep.
So
if you're looking for a more budget-friendly option, if you get this cover support, then the normal steel cam can handle the load, and the USA gear. Don't be putting on an old German gear. Bad idea. Boom.
One other thing, under this Keating valve cover, which is lower, we went with the Harlan Sharp roller rockers with their little support base. That's actually what we ran at UCC last year in the sled pull and the dyno after we broke broke our block. So they're proven reliable there. So this setup, we've ran at the drag strip pretty hard. We've ran this Harlan Sharp setup. So this setup has the Harlan Sharp roller rockers in there. We doweled them a little bit to make them a little bit more sturdy, and we've been very happy with this setup as well. So this is a little bit more budget friendly than the SMT setup, and it will fit under your valve cover. So the Harlan Sharp roller rockers and their bases is what we ended up putting in this one. So okay, one last thing on this engine, we put a 13mm pump on here with a really aggressive billet cam. It's about a 1,000 cc pump. It's just a little bit milder. If we end up having to run a big single or something, if we blow up all the turbos, we wanted a milder pump setup on here just in case. If we end up having to swap blocks and that pump is still good and we have a turbo system that can use the fuel, surely we'll put the 16mm on here. But because of this, we also are running a 5x35 dual feed injector that we built here in-house, where the engine number 1 has a 5x38. Now keep in mind, a factory 12 has a 5x9, so we're talking much larger nozzle than what you'd ever get.
Yeah.
So 1,000 cc pump on engine number 2. Engine number 1 has a almost 1,400 cc pump.
All right, I think that's about going to wrap up our engine discussion. We've been through this. I hope you stuck through the whole video. I know it was a lot of information, kind of real fast. We spent a lot of time working this together. Will has been on the phone with so many people in the industry, real high level, guys who have made some really powerful engines, and so we're pretty confident that we have enough engine to handle this pump, whatever it can handle.
And turbo system's coming along great. Tune in for the next video on that. It's got a pretty cool thing. Knowing that in the past we've gotten a lot of hate for our hot pipe. We said it looked like Helen Keller welded it, or Ray Charles with this feed or something.
It was me.
It was Todd. It wasn't Ray Charles.
All right, I'm gonna tell you something about that. So yes, I received a lot of hate as for how ugly my pipe was, and it doesn't bother me. You can throw all the hate at me. It really doesn't bother me. What I've seen though, and one thing that does make me kind of sad, is I see a lot of people who are hesitant to try stuff because they don't want to have the online scorn or ridicule they might get from somebody. Honestly, if I could have fixed my last hot pipe, I would have put it back on just to spite all the haters. Because literally that's the first thing I ever welded in my life. I taught myself to weld by building a triple turbo compound system because I knew it'd be too expensive to pay someone to do it. So I'm like, I just watched some YouTube videos on how to weld, and I got after it. So I highly encourage you, people. It was one of the funnest things I've ever done, and one of the most rewarding things that the first thing I ever welded did such an amazing amount of power. So if you have some idea there, I don't care what other people say. Go out, go have fun, make it, because it's freaking awesome. The stuff we're doing now, we have way more capabilities than I had in my garage at my house 5 years ago. So it's going to be better.
We have better welders, we have better machines and flanges and contacts, so it's easier to build the quality looking stuff. I mean, we've got Vibrant's helping us out, a lot of fittings and stuff, and yeah, we're going to have beautiful looking engines, but don't let that hold you back, man. Just, you know, be the captain of your own ship, do what you want to do, don't worry about what other people say, and go try it. Go try something new. It's a lot of fun. Yeah, one of our biggest desires here at Power Gym Diesel is to get people to go out and have fun and do things. So if you have an idea, just go out and do it. Go have fun. Can't stress that enough. Anyway, enough of my soapbox preaching. This is our engines. We're super excited. I really, really feel confident in these engines. And now we're going to go out there and tear it up, and it's going to be awesome. So yeah, wait for our turbo system install. That's going to be, because it really is pretty sweet. I got to admit it. Even though I love my old hot pipe, the new one's going to be way cooler. I do have one quick little thing, though, to add in the end here. What's your horsepower prediction for the dyno? We just got to throw it out here. What do you think? We didn't have the turbo system built, but what do you think is realistic we could do on the chassis dyno at UCC?
I think 2,500 is going to be a pretty achievable goal. Based on last year, we did 1,800 with a small valve head at 1,000 cc's, not the big cc's, while it was spewing fuel out the grill through a zip-tied hose.
So 2,500 is your guess?
I think 2,500 is a realistic guess, given those scenarios. I think we got 2,500. What do you think?
My guess, depending on the weather conditions, because that'll change the correction factor, is we're going to make about 50 more horsepower than anybody else. So if one of the other big competitors with triples or whatever makes 2,600, we're going to make about 2,650. That's my guess.
Is that even a guess? That's more like a formula. It's like an Excel spreadsheet. Here's my formula for my horsepower guess.
We're going to win by 50.
Win by 50. X plus 50. Okay, got it. Cell number 2 plus 50. Anyway, that's UCC. Update. You got anything else?
No. Like, subscribe, tune in. And next time, hopefully we're working on turbos, which are a lot of fun. And you'll see some of our new turbo fabrication stuff. Hopefully it's a little bit better for the internet haters, but if it's not, we don't care. We're just having fun, right?
That's right. Thanks. We'll see you next time.